I'm Anil Kumar, and in this video we'll discuss continuity of piecewise function. The question before us is, determine the continuity of the function f of x at x equals to minus 6, x equals to 1, it should be minus 1, x equals to 3 and x equals to 5. If it is discontinuous, state the type of discontinuity. So here is the function. F of x is equal to 1 over 3x plus 5 when x is between minus infinity to minus 6. Minus 6 is included there. It is equal to square root of 3 minus x from minus 6 to minus 1. 4 over x minus 3 when it is between minus 1 and 3. Minus 1 included. 1 over x square minus 9 between 3 and 5. And square root of x minus 4 divided by 4 minus 3 over 16 within 5 and infinity. Now in this particular example we have taken all kinds of functions which we are going to deal with. So I hope you remember how the parent function's graph is. You have to be sure when you sketch that the graph resembles the parent function. Now the first one, as you can see, is a linear function between minus infinity to minus 6. So these are the two limits. Let us substitute minus 6 and calculate the value. Now that is probably the best thing to do, right? Now right side limit is minus 6. So when I write minus 6 here, minus 6 divided by 3 is minus 2 and 5 minus 2 is 3. So at minus 6 I get 3 as my value, which is 1, 2, 3 on the graph. This point is included. Right. Now, as we approach minus infinity, this number will also approach minus infinity. Now, it is this line, we just need one more point to sketch a straight line. So let us find the x-intercept. X-intercept will be when the y value is 0, so we can calculate. So let me just calculate here. 1 over 3x plus 5 equals to 0. So that gives us 1 over 3x equals to minus 5, or x is equals to minus 15. So that is the x-intercept, 15 minus. So 12, 13, 14, 15. So if I connect these 2 points and then extend, then I know that this is my line, right? So let me just extend. So that is the first part. Okay. We'll use different inks to sketch each part, so it will be easier for us to communicate. Now, square root of 3 minus x. Square root of 3 minus x. And this is from minus 6 to minus 1. As we know, square root function is kind of like this, correct? It is kind, because it is minus reflected on that side. So it is kind of like this, reflected, it is going to be like this, right? Okay. At minus 6, let us evaluate the value. So it will be, if I write minus 6 here, it becomes 3 plus 6, which is equals to 9 square root 3. So at minus 6, I do get 3, so it overlaps. So it is continuous at this point, very clear, right? Okay. If I substitute minus 1 here, we get 3 plus 1, right? So the other point is square root of 3 plus 1, and that is indeed 2. So it will, at minus 1, the value is 2. So that is the second point. Since it is not included, we'll make open circle here. Now sticking with our structure of graph, I mean, it should be kind of like this. Do you get the idea, right? So that is how this part of the graph should look like. Okay. Now we have reciprocal function. It is transformed 1 over x, right? Now in this particular case, this transformed function, we have a vertical asymptote, right? This vertical asymptote will be at 3. Now this limit is from minus 1 to 3, so at 3 we can draw a vertical asymptote. It is a kind of discontinuity which will say infinite discontinuity. And we know the function is 1 over x kind of thing, right? So you know function 1 over x will be like that. That is the shape of the function, right? That is the shape of the function. Now at minus 1, this point is included. If I substitute minus 1 here, what do I get? I get 4 over minus 1 minus 3. Well, that is minus 1. So at minus 1, I get a value which is minus 1, and this is included, right? So we'll put a point which is included. Now, as x approaches 3, it approaches infinitely large value. You need to check whether that value is negative or positive, right? So if I write something which is, let's put value like 2. So if I substitute 2 here, then what do I get? I get 4 over 2 minus 3, which is, let me write 2 minus 3, which is minus 1. So we get minus 4, right? So at 2, we get minus 4 as our point. You can clearly see that you're going downwards. If I substitute x equals to 0, I get 4 over 3 minus, right? So slightly more than 1, but it is, close negative, right? So more than 1 negative, kind of like this. So what we see from here is that our graph has to come downwards, right? And you can have some more values. If I write x as plus 1, 4 over 1 minus 3 will give us 2 with the negative sign, so 2. So at plus 1, we are expecting a value of 2, so that's a good point to take. So taking these 3 points, we can draw our graph, right? So let me just sketch the graph here, approaching minus infinity. Is that okay? So we'll just show like this. So this is the left side of the vertical asymptote. Type of discontinuity, as you can see, is infinite. Now let's move on from 3 to 5. This is 1 over x squared minus 9. Now here also we have vertical asymptote at 3. 3 squared is 9. 9 minus 9 is 0. What happens at 5? If I write 5 here, I get 5 squared is 25. So let me write down the value, which is 1 over 5 squared. Okay, 5 squared minus 9. So 5 squared is 25. Let us calculate this value. 25 minus 9 is 16. So we get 1 over 16, right? Which is extremely small. So at 5, it is 1 over 16, which is here. But this point is not included. Let us make a hole here. This is 5. So let's make a hole here. So that is 5. Okay. So if I substitute other values, let us say 4. Then 4 squared is 16. So 1 over, so we can divide 1 by 16 minus, so let's divide 1 by 16 minus 9. 16 minus 9. So what do you get? About 1 over 7. So it is still a very small value anyway. But as we approach closer to 3, greater than 3, we are actually approaching towards positive infinity. So it's like very, very close, and you could actually replicate kind of like this. 1 over x graph transform. So that is the function which you get on the right side of this vertical asymptote. And this one, I use the same color anyway. Let me just darken this with some other color. So this is the whole, right, talking about. So this is a function which we use blue color with. Now we'll sketch the last part of this, which is square root function. So square root function should be kind of like this, right? Square root of x minus 4 over 4 minus 3 over 16 from 5 to infinity. 5 is not included, so 5, we have a hole here at 5 for sure now. Now, if I substitute 5 here, 5 minus 4 is 1, so we get 1 over 4 minus 3 over 16. Now, 1 over 4 minus 3 over 16. Let's write this down. So when I substitute 5, I get 5 minus 4 over 4 minus 3 over 16. That is to say 1 over 4 minus 3 over 16. And when I multiply both by 4, I do get 1 over 16. Right. So this 1 over 16 matches with our previous value, but both are whole. So this point is not included in the graph. Do you see that portion, right? Not included. 5 is not included. But the value is same, 1 over 16. So we have a point here at 5. It is 1 over 16. Let me write it down. Okay. Now, if I substitute higher values, I'm going to get a higher value, but it is going to be very low, right? Initially, if I substitute like 8 minus 4 is 4. Square root is 2. So 2 over 4 is half, and half minus 3 over 16 again is going to be a very small value, but definitely positive. So here again but it is approaching kind of 1. So let me sketch this graph like this. Is it okay? So that is how our graph is going to look like for the given function. Now clearly we can say that at different points we can discuss continuity now, correct? So at x equals to minus 6, which is here, minus 6, the function here at this point is continuous, so it is continuous. So the function is continuous at x equals to minus 6. At x equals to minus 1, we have jump discontinuity. So this discontinuity is called jump discontinuity. Here, right? So let me label it. Okay. Now here we have infinite discontinuity. And here we have a hole, which is another form of discontinuity. So this is an extremely good example where you can see all kinds of discontinuities, and also you can practice with different kinds of functions. I hope it helps. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.